Kia ora koutou, Kunik Jones, takunga, lovely to see you all. So here in the title of my talk, I'm channeling a colleague from eResearch Australasia who encouraged us to think about infrastructure as actually the most compelling piece of infrastructure is the people that we meet along the way. And I think we've heard quite a bit about this over the last couple of days, especially this morning on the panel. So, we'll talk a little bit about all of these people that you can see here, all these organisations. Many of them are in the room. This is the logo sheet of all of the wonderful organisations that we partner with in NeSI that really build the e-infrastructure, the e-science infrastructure for us here nationally. Many of them also work with you institutionally, and there's some other partners with your institutions that might not be on this slide. And all of those are welcome and wonderful parts of this ecosystem, this e-infrastructure, e-science ecosystem in New Zealand. What's pretty fundamental here is the collaborative values, the research expertise, and as Amber called out, that unique researcher focus that we hold very dearly in NeSI has been very core to our way of being, our culture, and the way that we engage with all of you, with researchers. So, we've updated that slide. So the two new people are very obvious. But these people are the power behind researchers. There's many. Who from NeSI is in the room? Can I get a quick show of hands? Okay, cool, thank you. Who's in the room that used to be at NeSI? Excellent. So, you know, our previous colleagues within the organisation are often still in the sector. We move around between roles and institutions, and research itself has a very long history of people staying in the sector and staying colleagues as well. So, collaboration and histories that last a long time in the sector. So I just wanted to cover off our sort of journey to where we are today. I'm going to talk a little bit more about the infrastructure and the services that we've been developing at NeSI. And you might have heard some other talks across yesterday, today, tomorrow that cover off on different aspects of this. So I'll try and keep it at a sort of a high level of services and talk about some of the change and what we value, what we really appreciate within the services, the value propositions, those sorts of things. So hopefully these are the sort of things that you'll see have that sort of continuity of service as we work together with Rianne's to look at that transition through to 1st of July and beyond. So if we go back to 2018, we had probably a quite traditional, small country, high-performance computing infrastructure. We'd gone through a period of change where we'd consolidated from 3 different HPC providers in the country down into one combined partnership with NeSI and NIWA, and a consolidated infrastructure out at the Greta Point facility in Wellington. But we were already seeing back then, and actually earlier even, that the sort of needs that were coming through from the research sector were for greater flexibility, for different models of service delivery, different types of software and data infrastructures to underpin the research that was essential to their communities, their teams, their organisations. And so we've been building this sort of pretty picture. I think this is one of Jun's pretty pictures. It's very lovely. Which tries to describe a little bit and tries to capture the sense that we've been building this sort of research cloud with different tenancies for different use cases. And so on the left you have the sort of hosting of raw infrastructure, specific facilities for AI, for GPU. We've got institutional partnerships, and you might have seen Ben and the team climbing towards the peak of Mount Aspiring yesterday. And so that's a whole of institution eResearch infrastructure that's in this environment. And then working with smaller teams on very specific things like the Aotearoa Genomic Data Repository, Kia ora Mick, and many friends, the Rakeora Human Genomic Indigenous Data Platform, So this is an environment where actually, above it all, we can fuse together the values and the sort of workflows and the data sets and the sort of kaupapa that we see as really fundamental to some of our big science ambitions, whether they're in human health, in the environment, in endemic species, whatever they might be. But all of this is within a combined platform, which at its sort of underpinning core, we tend to call flexible HPC. So it is high performing, but it's also more flexible than traditional high performance computing. So you can see there a sort of a journey through time as we've gradually sort of incremented and developed this platform through different use cases, through experimentation, learning and development, and multiple rounds of investment over time. So let's talk briefly about what we're well known for. I don't know why that little cat has only got 2 squares next to them. They're meant to have more emojis, but never mind. I think this is a Microsoft issue. So NeSI is known for its high-performance computing. Okay, and I think a lot of people think, well, that's all the blinky lights. It's the big machines, and actually Rick's machines are bigger than mine. So, if you're impressed by that, then talk to Giuseppe about exascale. And we do have HPC, small-scale HPC in the country. But what's always been different with what we've done is really focus on the sort of people and the skills aspect, because when we started, we didn't have a history of large-scale computation, big science, all of those things that drive the big scales of HPC internationally. What we had was a deficit of skills and experience and practice and the transformation of sciences that's been delivered by these sort of computational platforms. So we always tried to focus on making it easier to start, really trying to uplift the researcher to be able to come into this environment, and that's why the cat has love hearts in their eyes. So there are the traditions of command lines, and I think we heard this morning that the command line is not going away anytime soon. You're not going to be able to hide it behind beautiful websites, but we do interactive computing with notebooks and websites and those sorts of things, including data repositories. We also manage hundreds and hundreds of scientific software applications on behalf of researchers, so that researchers don't have to be the ones that actually manage deployment and provisioning of a huge range and array of software packages. And that's a huge value add. That's an efficiency that comes in when you can come in at scale with a breadth focus across the sector, and you can say, we can do this once for all of you. And you can come into this very rich, sort of fertile platform to do your research. And then there's lots of support, there's brilliant communities, all the way through to, this is it's either a spring, winter or summer school, I think with Kim Handley and environmental genomics, maybe. Yes, thank you, at Auckland. So we do get into education programs where we're working inside the universities, we do the carpentries, and all sorts of things. So that's been the classic HPC. It's really been an HPC that's focused around breadth and enabling and being highly supportive. As we were looking at this round of investment for NeSI, we needed to obviously refresh our infrastructure. We wanted to empower researchers with some of the latest and greatest technologies. We see this shift, this growth, driven by artificial intelligence, but also by a change in the technologies that the simulation communities were using. Because we talk a lot about AI, and we sort of relate that very strongly with GPUs, but actually some of the big users of GPUs are the simulation communities, because they're very good at getting more power, more scale, more efficiency. They've had decades of getting good at that. So when something new like GPU comes along, they're actually very good at adopting it. We wanted to look at consolidating our infrastructure footprint, because this new platform that we'd been developing was out at Tamaki, in Tamaki Makaurau in Auckland, whereas our longer-term platform had been down in Wellington. And so this round of investment was actually about, as well, consolidating out in that Tamaki position. The Greta Point data centre was coming to its end of life, so there were some key reasons from an infrastructure life cycle perspective that we needed to work with. And then really looking at that sort of responsiveness to the sector. You know, could we provide the sorts of services? Did we have the right sort of shape and form and flexibility of infrastructure that we could support the growing diversity of needs with a rich range of services? So the refreshed infrastructure within this flexible HPC cloud environment was bringing in an additional 10,000 cores of HPC and bringing in high-performance storage. We were switching storage platforms from our previous partner with IBM and GPFS, which has been our long-term partner in terms of high-performance storage, into a new partnership with Dell and Weka, backed by our Ceph object store. We were bringing in new cloud compute nodes, new object storage capacity, and thinking about particularly the sort of longer-term archive of data, so multi-petabyte sort of tape-based storage tiers, and then a new range of software in terms of how we sort of provision and manage the platforms. We had been somewhat locked into some quite proprietary software in terms of how we provisioned the old platforms. And if you're doing just HPC, that's all right. They're finally optimized for just that task. But we needed to break out of that and be able to provision more flexibly. Now, it was quite nice to see April's talk. I don't know if April's anywhere here, but her talk on HPE yesterday, and one of the trends was really looking around, well, supercomputers are doing this as well. There's this whole shift to really understand this breadth of sort of interaction styles and use cases and actually shift the infrastructure model to be able to support that richness. So what's new? What's sort of coming now that's sort of part of this infrastructure refresh? So we're adding a rich catalogue of sort of interactive applications and tools. We're replacing our current Jupyter-based service, which is our notebook service, with a much more flexible, sort of extensible environment. So we're introducing on-demand, and that's our new interactive notebook service. It's available now, people are using it right now, and the apps at the moment include the classics, the sort of Jupyter notebooks, the RStudio. We have got a version of this that we have also developed as an open source distribution that some of our colleagues, and particularly in Australia, were quite excited to pick up. And that has Visual Studio code in it and a range of other tools. But it's a nicely sort of packaged thing that you can just spin up on an OpenStack cloud, use for a training offering, use as a sort of ephemeral sort of platform. And gradually we're sort of extending this one to incorporate all of those as well. We've got a very well-developed range of curricula, of course materials, of open course materials that sit within our training environment, so machine learning packages, RNA sequencing with our buddies at Genomics Aotearoa, looking at the bioinformatics needs across the country, and we'll be adding those, and they provide a really nice sort of template as a scaffold, as a starting point, if you want to get into a bit of bioinformatics, or if you want to get into a bit of machine learning or deep learning. So having that sort of scaffold in there really gives you a place to start from, and again lowers that sort of threshold for how you might come into this environment. We have the new HPC, and this is really the latest, for a brief period of time, the latest HPC in New Zealand. There's more coming, which is wonderful as well, which will form part of that federated service model that Amber's alluded to already. And really bringing in the latest processors. We have a rich range of needs, including for large memory. We're going to bring forward our last round of investment from the last couple of years. So it'll be a mix of some of the old and some of the new, and really bringing in as well sort of the core sort of network interconnects and GPUs as well. And I think I won't get into the technical side of it. There'll be a talk from Blair, who's going to dig a bit deeper into those aspects of it. But I think that it's much more energy efficient. It's going to offer a lot more power for everyone, and I think the ability for us to upcycle previous generations either into HPC service or even into our research cloud become part of our sort of infrastructure refresh cycle. There are new H100 GPUs in here and L4 GPUs. There's a range of things coming through, A40s as well, all for different purposes. Some of them are good for training, some of them have got FP64 for high precision work. It really depends on what your need is going to be, and this is where we're starting to see more optimization of specific types of GPU and specific types of workload within the community. There's been a lot of work over the last probably 7 years in NeSI to try and lift the uptake of GPU nationally. It's still operating at a relatively small scale, and the signs are that this is an area that's ripe for investment. There's every sort of week at the moment we're starting to get people coming in saying, can we have this LLM? And you sort of work through with them, what does that actually mean? And the short story is it's quite complicated. But what we have is that appetite within research communities to really adopt these tools, but they're coming from a standing start. They know that their colleagues are using these internationally, they know it's what they need to upskill themselves on to remain competitive, but how do they get there? So there's a really key role for us all in terms of how we sort of, again, lower those barriers, lower the threshold for them to get involved in that latest science. We've got I've mentioned Weka already, so we're modernising the data storage stack, and we're moving from the sort of classic workhorse of HPC, the IBM GPFS system, which we've had for a few decades. So this is going to give us sort of trailblazing performance, but it's also going to have that workhorse reliability. So Weka is well proven at large scale and in some of the peak facilities around the world. But it also has a wider range of features than we're used to. So it can deliver object storage, it's got multi-tenancy, it's got a range of features which will really help us with that flexibility over time. So we're really looking forward to what comes as that sort of settles in and becomes the core platform. We're taking a fresh look at how to support managing research data for the longer term. So we're replacing our somewhat creaky tape back to nearline service. It never really got out of early access. Do not try and develop one of these tools yourself. You will regret it, and it might take you a long time to move on. So once you do move on, though, it's definitely a brighter day. There's a lovely bright future out there. So we've chosen Versity as our tape back storage tool. It does tearing out to object and out to our tape libraries. And as other people in the sector might also be consolidating into that solution as well. So it gives us a very nice, easy interface for, much like the Glacier platform in the cloud, for storing data longer term and bringing it back. Common interfaces like the S3 interface, that sort of thing. A lot of these services are not just the sort of the storage function or the CPUs and GPUs compute function. They're actually a service layer, a set of ways of interacting with the hardware, the infrastructure, to undertake your workflows, to do your science. And we've been building a lot of those more complete services ourselves based on our OpenStack flexible HPC platform. Now that's our developer platform that we use internally to NeSI. But actually a lot of institutions need that sort of cloud-like internal platform to be able to develop these sorts of solutions. And if you go out to industry, it's very common these days to see institutions providing first-class support for the software developers. And we heard Giuseppe sort of saying this morning, software is infrastructure. So while we've had data platforms and HPC for a long time, we haven't privileged or prioritised how the software engineer and the software developer in science has actually been supported by platforms. And so the Research Developer Cloud is providing a set of blueprints and support and scaffolds for researchers to come in, for those researchers who are actually developing solutions, the sort of research software engineers, the people in your informatics departments, the data science engineers, who need more like a cloud-like style environment but still want that sovereignty in New Zealand. They still want it to be adjacent to the same high-performance storage, to the HPC, so that they can really articulate a really sophisticated set of workflows within that high-performance integrated environment. So that's the Research Developer Cloud. It's programmable. We see that as being an environment where shared responsibility is really fundamental. It's all about partnership. We need to sort of upskill each other so that we can adopt the right security postures and we can maintain code and make sure that we're looking after things in the right way. And we see it as a really interesting part of the ecosystem. It's really making available to everyone else the sort of power of a platform that we use ourselves to craft the sort of services that we offer to you all nationally. So we're on the way migrating to our new home. We're aiming for that consistent user experience with the infrastructure migration and with the NeSI and ReENS transition. There's a theme there. On-demands there, Freezer and HPC are coming now. We've got data moving. We've just doubled the rate of data transfer out of our Greta Point facility to our Tamaki facility in Auckland, which is wonderful. And we're really humming on the ReENS network there, which is awesome. And we've got some early access users in a bunch of these services, but we're about to move into that in earnest. So we've had to do a lot to get to this point in terms of refreshing the data center, getting kit in there, changing the pod structures, the cooling infrastructure, the power infrastructure. We've retooled how we provision all of this infrastructure. We've adopted as-code approaches for pretty much everything. So we now have more of a developer-centric model of delivering and maintaining our services. You can see that lovely flow of data going to Tamaki there on the left-hand side. It's an elephant flow for sure. It's one of the biggest flows we've seen on the network recently. And it's pretty exciting to be heading towards this new environment. It provides a fantastic flexible home and hub for infrastructure and for integration of new and emerging infrastructures as we think about the future of e-science and eResearch in New Zealand. So come and hang out with the team anytime you want. There's always online office hours on a weekly basis. There's lots of training going on. Reach out. Everyone's always keen to talk to you. Unuhia, ki te uru, tapu nui, kia wātia, kia māma te ngākau, te tinana, te wairua ki te ara tangata, gaia rā e rongo, whakairehia, ake ki runga, kia tina, hui e, tā i ki e. Thank you.